step in a little bit more.
Carly, what did we think
Yeah.
of last
You need to step in. We can't even see you.
Yeah, I didn't know.
And we're recording.
Who did his
We're
makeup?
6 seconds in.
Alright. So today what we're going to do is we are going to look at being able to measure and sketch an angle in standard position. We also want to be able to find coterminal angles, and we'll define what that means in just a second. So as we go forward here, we need to define some vocabulary, because there might be a few new words here that we're looking at. One is standard position. Standard position, following. When the vertex of an angle is at the origin, which we know to be 0, 0, and one ray is on the positive x-axis. So we know our x-axis goes horizontally. When it crosses the origin, we always want the portion, one ray of our angle, should always be going to the positive x's. Okay? That's standard position. The initial side. The initial side is the ray on the x-axis. So if you think about an angle, you're going to have two rays. One here, maybe it's over here. Kind of depends on the angle. The first ray must, initial means first, right? The first ray must be drawn with a dot on the origin and an arrow out in the positive x direction. The terminal side, so if we have two sides in an angle, we have the initial side. The terminal side, well, that can change. That is the ray that's not on the x-axis. So we don't know where it is. We just know that it's not on the x-axis. So we have initial, starts at the origin, goes along the positive x-axis. We have the terminal side, which is not on the, and I actually should add in this word, it's not on the positive x-axis, because it actually could be on the x-axis in the negative direction. Okay? And the last thing we need to know is coterminal angles. Okay? Think about cooperate, commiserate. Anytime you see the word co, it means together. Okay? It means kind of linked, that they're this, dealing with the same thing. Two angles, two different angles, that when in standard position, so when we have that first ray on the x-axis, we'll have the same terminal side, and we'll look at how that, how we form coterminal angles in just a minute. All right. So two things we need to know. We need to know, how do we measure angles? Well, we know that positive angles are always measured in a counterclockwise direction. Seems kind of against what you would think, but we're always going to measure them this way. So you're going to go starting here, starting at your initial side, and you measure counterclockwise if you're talking about a positive number. However, negative angles are always measured clockwise. So we have positive counterclockwise, and negative should be clockwise. Okay, so again, we need to make sure we're starting from our initial side. So you always start from that initial side and measure clockwise if you have a negative, counterclockwise if you have a positive. So let's look at a few pieces. If I'm asking you to measure an angle, okay, and I were to tell you that this right here is 30 degrees. What is the measure of my angle? Well, first of all, I'm going to look at my direction. My direction here is clockwise, so I know it must be a negative. Clockwise is negative, counterclockwise is positive. And I know that each quadrant, remember this is quadrant 1, 2, 3, and 4. Each quadrant represents 90 degrees, such that if you went through all 4, you would go 360. So 90 plus 90 plus 30, that's going to give me negative 210 degrees. As I look here, I see that I'm going counterclockwise, which means I must have a positive angle. I see that it goes all the way through the first quadrant, so that means it's got to be bigger than 90. And I see that from my terminal side to the next, through the next quadrant, through the second quadrant, is 60 degrees. That must mean that this angle right here is 30. So we have 90 degrees over here, plus 30 degrees there. This must be a 120 degree angle. Positive because we're going counterclockwise. Down here, we see the initial side is here. We know that we go through 2 quadrants, so that this is 90, this is 90, and that this right here is 45. So just like up here, where this excluded portion was 60, notice 60 and 30 is 90, 45 and some number is 90, which we know to be another 45. So 45 plus 90 becomes 225 degrees. A second to add that there in my head. But note, guys, the first thing I've done on all 3 is look at what direction it's asking me. If it's asking me counterclockwise, it's going to be positive. Clockwise is negative. Now, if I'm asked to sketch some angles, let's start with a nice, easy one. As I look at 48 degrees. 48 is positive, which means I'm going to draw my initial side. I could actually draw my initial side on all 3. I know I'm always going to be measuring in standard position. Now I just have to think about direction and how far. Direction here becomes, well, that's almost half. It's a little bit more. But remember, we trust our numbers. So as long as you have it in the right quadrant, approximately where it should be, this angle inside here is 48 degrees. Okay, and I like, for me, when I'm measuring on a coordinate plane, I like to put a little arrow because it reminds me what direction I measure in. Okay? Over here, we have 245 degrees. Well, as I think about some of the angles that I should really know, I know this is 90. 90 for 1, so this first one is 90 here, then we get to 180, then we get to 270. 9 plus 9 plus 9, add your 0. 245 is less than 270, but it's only 25 less. I'm going in the positive direction, like that, and this becomes my 245 degrees. Now let's look at a negative one. We have a negative measure here, so we know we're going to go clockwise. I have my initial side. I note that this is less than 90, but quite close to it. Again, I like to use my arrow, and that's my negative 79 degrees. That's how you would sketch an angle in standard position. It makes it really easy because no matter what it is, we always start with our initial side being in the same place, and then we just go one direction or the other. The last thing we're going to have to do is we're going to have to find a coterminal angle. So we need to find angles that would give me the same terminal side as the initial angle. So if I'm looking for things that need to have the same side, I'm going to start out with my initial side, and I'm going to start out by measuring this angle. It's positive, I know I'm going to go counterclockwise. It's bigger than 90, less than 180, so I know it must be in quadrant 2. It's about 20, it is 21 degrees greater than 90, so I know that this is here. It's 111 degrees. This is the first angle they gave you. Now you need to find another angle that will give you the same terminal side. Well, when I think of another angle, there's two ways to do it. One, just go the other way. So if I were to go that direction, what would my angle measure be? Well, it would be 360, one rotation around, right? Subtract 111. Okay, 360 minus 100 is 260, minus 11 is 249 degrees. So I know that this angle is the numeric value that I want. Now I have to think about my direction. So it's sort of the opposite of what we did when we first draw this one. I need to go clockwise, so this becomes negative 249 degrees. Now I said that there was two ways to think about this. If I wanted another positive angle that goes in the same direction, okay, that has the same terminal side, what would I have to do? Well, I'll draw my 111 again. This is 111 degrees. My next step, guys, would have to be, if I wanted another positive angle, to do this. I know that that's how many degrees? 360. And then I'm going to go here, such that 360 plus 111 would give me 471 degrees, and it's in the same direction, so it stays positive. I could go 2 times around and then to my terminal side. You can always add a rotation if you want to go through the same direction and the same side. So the last thing I want to look at is when our degree is bigger than 360. So when you look at something like negative 400, the first thing you think about is that you're going to be going clockwise. Draw your initial side. Now I'm going to go 1 full rotation for 360 and 40 additional degrees, such that this is a negative 400 degree angle. Again, there's my little arrow to help indicate. Now when I label this, one of the things that I would do is actually label just this little interior angle here. We know that we started with negative 400, but that we had to go 40 degrees past negative 360. So, now that I know I had to go 40 degrees past 360, a coterminal angle, if I asked you for a coterminal angle between 0 and 360, you could say negative 40. All I have to do is take out that first rotation, and it's whatever ends up here. Another one could be 360 minus 40, or positive 320.
You want us to write
Both of these are coterminal angles. If I ask you for one, just write one, it doesn't matter. If I ask you for more than one, write more than one. Okay? So what you have is 360 degrees plus 40 more, right? Okay, and that can help us get to our initial shape. Then we realized we could have gone just negative 40 and it would have gotten us to the same place, or we could have gone positive 320. Questions? Yes?
What would be that 320 degree angle? Like,
The red arc here.
okay.
90 plus 90 is 180, plus 90 is 270, plus whatever this little piece is here, which becomes, in this case, 320 minus 270, which is 50.
And for the other one,
Uh,
are there two coterminal angles there? There's 249 one.
there is always an infinite number of coterminal angles, because all you have to do is continue to add full rotations. So if I did 6 circles and then went a little bit, that would be a certain degree measure. If I went 5 circles, if I went 100 circles, and then a little bit, I would always have it. Yes?
So even if, like, I'm going back to, like, the 111,
Mhm.
so even though it's, like, 360 minus 111 and it's not a negative, because it's going clockwise, you're going to change it to a negative.
Absolutely. When I do my 360 minus whatever my angle is, in this case to get 249, like the first example, I then have to think about the direction, put a negative if it needs to go clockwise, and put a positive if it needs to go counterclockwise, because the goal, guys, is to get to the appropriate spot. And 249 is not a coterminal angle. Negative 249 would be. 249 would bring me right about here. That's not the same place. The definition of a coterminal angle is such that the terminal sides of two angle measures in standard position are the same. And that's it for those 3 things.